Hi everyone, welcome to the Neural AI podcast, where we'll be delving into AI and its various subdomains. We'll be exploring an array of topics like generative AI, recommender systems, deep learning and reinforcement learning. We'll explore how this intersects with various industries like retail and healthcare, and we'll do this by chatting to thought leaders in the industry who share their personal journeys of perseverance, use cases and technical challenges. Besides this, we'll also have some fun along the way, discussing future predictions. So sit back, relax, and enjoy. So, welcome, Gilbert, to the show.
Thanks a lot, Chris. Nice to see you again.
You as well. So, let's just get straight into this. I always like to start at the beginning. I think it's a good place to start. What kind of got you into AI and made you choose a PhD?
Good question. So I was very interested in self-learning algorithms. At the time, I studied electronic engineering, right? And control systems was my favorite subject. So this was back at the times of closed loop control and autopilots, automation, that sort of thing. So neural networks were going through an AI winter still when I was looking to start a PhD. But there was a lot of movement in probabilistic models and that type of Bayesian machine learning. So I saw an opportunity to further the research in that field. I was definitely interested, and I was also very interested in Internet of Things. The engineer in me loves connected devices. So I guess it was a bit of being in the right place at the right time. There was a lot of buzz around applying AI, NLP to the Internet of Things, and I wanted to do my research in that area, and I went for it.
Yeah, cool. And I guess a lot's changed since then and now, and I guess unless you're going into a purely research-driven role, do you think a PhD is essential now to go into a general machine learning role?
The PhD itself, no. But the willingness to do an equivalent amount of learning, self-learning, is imperative. So what makes you successful through a PhD is you are pushed to learn on your own. You do your own research, your own literature review, and you don't go to lectures. You've got a research question you're trying to answer, which lends itself very well to the work in AI ML, where there's a lot of open-ended questions. The route to the correct solution is not exactly clear and linear, and you need to be able to adapt and find that answer for yourself. So it's not so much the credentials of having a PhD that opens the door, though, of course, it's always nice to have some evidence like that for a prospective employer, but it's not the only way you can show you've got those skills. You can share your Git repo, for example, or publish your own articles, your own papers to show that you've got the domain expertise. But there is no getting away with without doing the equivalent amount of work, is what I'm trying to say. You can self-teach yourself without doing a PhD, but you need to be willing to put in the work.
Fair enough. And fast forward to now, do you want to just talk people through kind of your role and how you're applying kind of machine learning to the energy sector?
So the energy sector is very interesting because it's so asset heavy. So there's, again, a lot of instrumentation data coming from IoT devices. There's a lot of decisions that can be made almost completely automatically, or at least semi-automatically, and they're not open to subjectivity. Like uh, take marketing domain for example. Whether to put the right offer in front of someone is still um, slightly subjective, whilst when it comes to how do you fix a piece of equipment, what's the right information to bring out from a catalog, or when is it most likely to fail, you can be a lot more objective. And I find that it helps. It lends itself very well to AI and automation, and also with the majority of people involved in the field being from technical or engineering domains, it's also a bigger appetite for using AI and for automating things. Um, Now, so that's why I gravitated towards
Mm.
there. The opportunities are vast because um, it's first of all, it's something that impacts all of us in the UK when it comes to low carbon infrastructure, right? We're moving towards offshore wind, electric vehicles, charging points, and the infrastructure needs to expand when it comes to transmission and distribution. And that's for the social good of all of us. So it gives you quite a good feeling when you're solving these kind of problems, helping with critical national infrastructure that benefits all of us. Um, you're looking at things like, how do I accelerate capital projects? How do I help them select the right sites where to put a new base station, new infrastructure quicker? How do I optimize construction schedules? How do I dynamically adjust um, to unexpected events and still try to keep the construction schedule on time? How do I use generative AI to check that I'm collecting the right asset information that is required for commissioning without needing an army of people to check all of that? Because the problem you've got is scale. We need to build new infrastructure at 20 times faster than we've ever done before.
Mm.
And it's an industry that relies heavily on experts, on trained people. So how can we use the small pool of people that are available in our country and allow them to essentially achieve more? And that's through augmentation. And generative AI is very key to that. It can summarize things for you. It can extract the information for you quicker. It can help you generate regulatory filings and reports quicker and things like that.
Mm.
Um, and all the way across the spectrum, right? Intelligent asset maintenance is another key thing. We've got such an aging infrastructure, the grid, the water network, detecting leakages, for example. But 30% of the water that gets pumped into the UK pipelines leaks out.
Mm.
That's a huge infrastructure problem right there, and
Mm.
being able to predict a leak or localize where a leak is happening and send someone to fix it quicker. Again, that's a very cool AI problem, and I could go on and on. There's loads across the spectrum. I'm very passionate about it, as you can tell.
Yeah, it definitely sounds like. I guess there's no one better to ask this question to than you go into many organisations, look at what they're doing, how they're doing it. What would you say is the most common mistake when an organisation is looking to implement AI or generative AI? What do they potentially need to do beforehand?
It's underestimating. So it's more of a problem of underestimating what needs to go into scaling out any form of AI, not just Gen AI. So doing proof of concepts, relatively easy, relatively contained, but in order to deploy something, you need to have a clear route to life. You need to know or have a plan of how you're going to monitor it, how you're going to calibrate it, how you're going to measure what value it's going to bring. And so it's not just about showing that the technology works. That's the easy part. In fact, I would say in 2024, you are wasting time if you're trying to show that AI works on your data,
Mm.
because probably someone has already proven it. Um, and I would say if you're serious about using AI, think more of what's my route to life going to be? What skill set am I going to need? Because it's not just data scientist. You need a project manager that can manage such a project. You need the architects. You need to um, think business analysts. You need to think DevOps. So you template everything and harden the solution before you deploy it. Who's going to test it? How is it going to be tested? So it's really not that different from any other IT project in a sense. But or at least if you can start with that kind of template, but then you have to think, okay, what does this mean in the context of an AI project? And I think that's where most organizations make a mistake. They think of it as a experimental, a lab thing that doesn't fit the rest of the patterns they've got for deploying IT solutions, and
Mm.
then they get stuck because or they need to course adjust, and that takes time because they almost have to go back from the beginning, the first stage gate, and then move through the required stage gates as it should. I think a common misconception is that they need to have the uh, fully clean data foundations to get started with AI. That couldn't be further from the truth. More so as we jump into the realm of few short learning, transfer learning. Modern AI is pre-trained on vast amounts of data, and all it takes is a few examples to fine tune them to your particular problem. And I don't mean just Gen AI, it's the same for computer vision, it's the same for forecasting models. It's become highly commoditized. So I guarantee you, for more than 80% of the AI use cases you will be thinking of, you could get them done without needing much training data clean and ready to be able to instantiate them on.
Yeah.
Um,
Uh,
and I can go on, but those tend to be the most common
yeah.
problems.
Makes sense. Thank you. And I think you've touched on it a little bit there, but where can something like generative AI, let's use that as an example because it's the biggest buzzword in the market at the moment. Where could that bring the most value to the energy sector?
Oh, I do believe that new infrastructure, new low carbon infrastructure, is uh, the biggest opportunity. Anything from how you service new connection requests, collecting that information with Gen AI, being able to guide people who are requesting a new EV charging point or a new heat pump, um, frees up a lot of time from the planners who are currently on the phone trying to explain these things to people rather than doing value add work like planning how to improve the network. Um, there's a big opportunity on the retail side to help people make their energy bill cheaper. So I see a world where energy providers ping you, and Gen AI consumes your smart meter data and tells you how you based on your patterns, what tariff works best for you, and also how households in your same street of similar size are keeping their energy bill cheaper by doing X, Y, and Z, and explaining to you how you could adjust your patterns. I think those are two big, immediate, quick wins.
Yeah, okay, understood. And I guess generative AI and critical infrastructure potentially don't go together straight away, or there could be certain ethical implications. How do you ensure that what you're doing is ethical and the models that you're deploying are safe and secure?
So a lot of thought goes into this. First of all, if you use third-party vendors now, you get a lot of guarantees that your data is not going to leave your virtual private cloud, that it's not going to be used to retrain any models, and then make it available to other of their customers. So there's a lot of safeguards that way. Keeping responsible AI in mind from the get-go is paramount. It's all about understanding what could go wrong with deploying this AI, things like hallucinations, for example, jailbreaking, but there's guardrails you can put in place for all of these. So just like any other IT system, it's got vulnerabilities. The only way to not have vulnerabilities, potential vulnerabilities, is to do nothing, which is not an option, right? So the important thing is understanding what could go wrong. Could someone ask it a certain question that would prompt it to give secret critical information? Yes, it could. Can you make it such that it physically cannot spit that out? Yes, you can. There's plenty of things you can do, including never showing that data to the model in the first place, completely air gapping it from it. So, in short, lots of risks, yes, but also the risks are very well understood. And as long as you take that into account from the get-go when you're designing the solution, it's proven that you can mitigate all of those risks. There's very well-known ways to do that now.
Understood. And I guess next point, if there is a stakeholder or stakeholders that you've dealt with in the past, and maybe they're risk adverse to AI adoption, what kind of objections have you seen in the past? And I guess if someone was looking to implement themselves, what advice could you give them to get stakeholder buy-in?
So education is the first step. So you always fear what you cannot understand. And if you're in a position where a lot is at stake, a lot could go wrong, being cautious is the right thing to do. So I'm not saying that would have been a bad decision to make, but the next step is inform yourself, understand what it can and cannot do, understand how to put guardrails in place for the things that could go wrong, because some things you can completely remove the risk from them by design. Like, for example, if your fear is that the certain information about critical national infrastructure could be leaked out by the model, just don't show it to the model in the first place. Completely air gap it from it. The model cannot physically reach it on the network unless you need it for the particular use case. But I would say don't start with a use case like that. Start. RAG is a very good place to start, where can you get the right manual, as in supplier asset manual data to your engineers, which, I mean, these catalogs are out on the internet. The suppliers will have them out of the internet. So it's no secret information. It's just there's reams and reams of it, and one catalog can be more than 1,000 page long. So build a system that uses Gen AI to get that paragraph or page that the engineer needs right now to do maintenance on that particular asset straight away. That immediately saves volumes of person hours searching for the right information. So this is the advice I would give to decision makers. Find use cases that are high volume, low complexity, and very safe to implement, because chances are that data is already in the public domain anyway.
Okay, that's brilliant. Thanks for sharing. And again, I think you touched on it there. Use cases. Something I'm always keen to share is, the value that AI can bring, and share as much of the success as we can. Do you want to just talk people through a recent use case you've had with Gen AI, or anything that comes to mind?
Yes, I mean, as you can imagine, we get involved into all sorts. One of my favorite recent ones is helping a capital project to extract the information they need from supplier documents to populate their digital asset register. And when you're commissioning a big plant or any kind of capital project, you at the end need to check that you've got the relevant information in your asset register. And to populate this during the years it takes to build a capital project, it's very labor intensive. Like, you're talking loads and loads of people opening catalogs that are thousands of pages long, just to extract the few lines of information that would go into the asset register. So we've recently automated that for one of my clients, and we've proven that the AI achieves over 99.7% accuracy, which is great, because you need to make sure that you can trust the AI, and you do that through statistically significant spot checking, just like you would if you had armies of people extracting this data, because they're prone to human error. So it was really good to show that AI is truly capable of doing this on its own, and maintain an error rate which is much lower than human beings would. That was a really interesting one. Another one that I've worked on recently, but it's still in development, is contacting vulnerable customers in case of an outage. So there's, think people with kidney machines, or who have chairlifts in their house, and imagine in the case of an unplanned outage, these people's lives could be at risk. And it's really difficult for any company to suddenly make, say, 2 million calls and check that all of them are okay. But imagine with AI, you could make 2 million calls simultaneously, and you could check whether these people are in a difficult or life-critical situation, and call the emergency service to their premise straight away. I think it's a big game changer in terms of keeping people safe and completely rethinking how we look after the vulnerable in our society in times of need, like big unplanned outages.
Yeah, I think that's amazing. I think what you see in the news are first to report any risk, but sometimes we forget the potential force for good AI can be, and solving real world problems with AI is fantastic to see.
Mm.
Cool, thanks for sharing those. And I think moving on to the next part, you've managed huge teams of 100 plus, and specifically in consultancy, that can present challenges of finding the right technical people, but also the right communicators. How do you decide the composition of your team when trying to build out teams?
So I look at the upcoming trends. So, for example, if you've asked me 2 years ago, the very clear gap in the market was MLOps, where customers were having trouble was not with finding as such the people to build the algorithms, but the people to harden and scale out the algorithms. So that was a skill I prioritized, and you understanding the spectrum of that as well, because it's really hard to find someone who is able to tick all the boxes across that spectrum. But you could have people who cover this end of it and others who cover that end of it, and then through a whole practice, you've got enough diversity to cover all bases. And I find that building a successful practice is more like that, rather than trying to find these unicorns. It's more a matter of finding people who are strong enough at a high enough percentage of that spectrum. And then there's also the upskilling part where being able to provide them with the right training. We have a partnership with Workera, for example, which proved to be indispensable because it really gave a step change in people's skill spectrum. It because it kind of gamifies upskilling, and you could really see how things that skill sets that you found it hard to staff on a project a few months before we brought it in compared to looking at a few months after. It became much easier because people upskilled, it plugged the gaps. So it's not just a matter of plugging them through recruitment. You can, as long as you bring in people who are willing to learn, have that appetite, have the ability to ingest new information, you can then plug that little delta that you might have. But yeah, I'm always looking ahead. I think the next trends are going to be in the decision optimization, reinforcement learning. I think that is the new frontier after generative AI. It's being able to recommend the next best action to take, help humans optimize the decisions they make. So anything around reinforcement learning, recommendation systems, people who are good at designing simulations, because these type of AI generally rely on scenario modeling and being able to project scenarios into the future. So I see that as being something to think about over how to hire over the next 2 to 3 years as well. Imperative right now is, of course, generative AI and LLM ops.
Yeah, and I guess with things like reinforcement learning, having a human buffer there is pretty important at the moment. But do you see a future in the near future where AI is fully automating decisions? Maybe not for critical infrastructure, but
Um, so Meta just released a interesting paper to that effect, and I think yes and no, as in um, definitely to scale out, we need to have uh, more of these self-sustaining feedback loops where um, models are used to provide feedback to one another, and there's techniques that are decades old that might start to resurface here. Like one of my favorites is using genetic algorithms to create new architectures that you could train the model on. So essentially, you've got a AI that is learning to reconfigure itself and make itself um, able to generalize more, able to learn better on your particular domain. And I'm sure it's hard to tell what's going to be the silver bullet, but definitely it's going to go in that direction. But I think you're never going to fully get rid of the human in the loop, because if it's just AI feeding back to AI, more often than not, we see model collapse, and maybe someone will fix that problem. But at the moment, what tends to happen is the errors and biases eventually start stacking up on top of each other. And if you're not careful, the essentially the model just collapses on itself. It starts learning gibberish.
yeah, fair enough. And this next bit just a little bit of fun to close things off, and not just contained to energy and nuclear, but what areas of AI are you looking forward to seeing kind of implement and work its way into society? What problems are you looking forward to it solving?
So I very like the idea of computational twins. So this is where you use generative AI to create forward-looking scenarios that are realistic, follow similar patterns to historical data, but you're not bound just by what happened in the past. You can generate reliable future simulations on top of which to then run optimization algorithms or deep reinforcement learning to try to find the best outcomes. And think about it. You could highly optimize the way you route traffic, especially if uh, um, all your cars and trucks on your road network are self-driving. And you could really optimize the distance they keep from one another, the speed they keep to maximize the throughput of your road network. To anything like optimizing the energy usage of large clusters of buildings, where the heat dissipates from one to the other, etc. Again, reducing our carbon footprint by really being uh, optimized in the way we use energy. Yeah, I really love these kind of scenarios that rely on computational twins, and that's certainly one area that gets me really excited on future possibilities.
Yeah, I think that would be good, wouldn't it? So, and final question: it is potentially a machine learning engineer looking to get into consultancy, or anyone from a really technical AI background. What advice could you give someone looking to go into AI consultancy?
Um, be willing to keep learning, keeping an eye on the horizon and what's going to be the next thing, keeping ahead of the curve. basically, because it's all about constantly upskilling and reinventing yourself. Um, it's such a fast-paced environment, and what could be a very rare and unique skill set right now, in a matter of a year or two, will likely become highly commoditized.
Mm.
So it keeps things exciting because you'll never get bored, but yeah, you need to be willing to upskill and constantly stay ahead of the curve. It's definitely fast paced, but also highly rewarding if you love learning and get bored easily, like I do.
Lots of variety I've heard. So yeah, thank you so much for coming on today. I really appreciate your time, and yeah, we'll look forward to sharing this with the listeners shortly.
My pleasure. Thanks for having me, Chris.
Thank you.